Now, dependent sources differ from ideal voltage and current sources in that they depend on some voltage or current existing elsewhere within our circuit. That is, if we look at a current-controlled voltage source, or a CCVS, our output, VD, is equal to our gain times IC, where IC can be a current either going through a short circuit or through another element within our system. That is, our output is going to be proportional to a constant, our gain, times a current existing elsewhere within our system. Now, a voltage-controlled voltage source, or VCVS, has a voltage output VD that is equal to a gain, B, times a voltage V sub C that's existing elsewhere within our system. A voltage-controlled current source, or VCCS, has an output, ID, which is equal to a gain G, times a voltage VC that's existing elsewhere within our circuit. And lastly, a current-controlled current source, or CCCS, has an output ID that's equal to the gain times IC, where IC is existing elsewhere within our circuit. Now, if we look at our unique gains, starting with our CCVS, the gain R has to have units of ohms. This is quite evident because our output, VD, is equal to RIC, which is following Ohm's law. Therefore, your gain is going to be a constant numeric value with a unit of ohms. Now, if we look at our VCVS, our gain is going to be dimensionless. That is, B will have a scalar value and no units associated with it, such that VD is equal to B times VC. If we look at our voltage-controlled current source, our gain has to have units of 1 per ohm. That is, ID would be equal to a scalar value of G with units of 1 per ohm times our voltage, VC. Lastly, our current-controlled current source will have a gain with units dimensionless. That is, ID would be equal to D, a scalar value, times a dimensionless quantity, times IC. Now, these sources are quite helpful, for they're used to model transistors and amplifiers. In particular, when we talk about operational amplifiers, we will re-express our amplifier as a dependent source. That is, the output is going to be dependent upon some other characteristic of our circuit. Lastly, it should be noted that our gains, R, B, G, and D, often are referred to as K, the gain of the system, where R, B, G, and D are not unique variables, rather just a placeholder to indicate that that variable represents gain. Now we can represent our dependent sources as follows. Starting with our CCVS, we can say our output VD is equal to R times IC, where IC can be represented as the current flowing through a short circuit. Looking at our VCVS, we can say VD is equal to B times VC, where VC can be represented as the voltage potential across an open circuit. Looking at our VCCS, we can say ID is equal to G times VC, where once again VC is the voltage potential across an open circuit. And lastly, looking at a CCCS, we can say ID is equal to DIC, where IC can be represented as the current flowing through a short circuit.